I was looking just for this show, I was looking to see, can you get a degree in a lot of types of engineering? You can't get a degree in them. You just get them by getting industrial experience in the area.
Okay, so let's move on to chemical engineering.
A chemical engineering course applies chemistry in the world, and essentially, like in this case, it involves the engineering part of process, because most of chemistry is a process, and so you develop ways in which you can process
food and medicines and things like that.
Could be that, yes. Although that's a combination. Like medicine's a combination, biology and chemistry, but a lot of chemistry in drugs themselves. There's a lot of chemical engineering in that. But I'm thinking more in terms of, say, fertilizer or gasoline or whatever, and then of course develop the areas like petroleum engineering, nuclear engineering for nuclear power plants and that sort of thing. And also, of course, aerospace engineering and all of that's where you build things that fly or whatever, or at least have air moving by them.
Okay. Software engineers, a relatively newer category, right?
Right. Remember, yeah, I think I had mentioned earlier to you that, software engineers, there was a lot of challenge in accepting software as a discipline itself in engineering. And eventually even the IEEE, the Institute of Electronic Engineers, brought the computer engineers, the programmers and what have you, software engineers, into engineering, because otherwise it was a rival organization that was going to kind of take them over if they hadn't done that. But it turns out that the electrical engineers were around the computers when they were developed, and so they were the programmers. That's where essentially they came from. And then eventually a separate discipline evolved, and there became an argument, because that's really a combination of mathematics and engineering.
And computer science, right?
Computer science, right. Which again, computer science is a brand new science, and again, there's arguments whether it's really a science, but there is, and you can get a degree in computer science now. So if you really want to stay in the software discipline, that would be the degree most likely you'd want to get. Though a lot of software programmers and firmware engineers, software engineers are electrical engineers.
Okay, and then the last one you say biological or biomedical.
Right, and biological and biomedical, these are the emerging markets now where you're taking biology, the science of biology, and applying engineering concepts to it. And it's very, very new and evolving rapidly. And I suspect it would be, the real up-and-comer. Of course, everyone says it's the up-and-comer now, because it is. It's the new field. It is the new field that would be like electronics was when I was younger.
Yeah, did you distinguish, by the way, between electrical engineering and electronics?
Yes.
You did.
Yes.
Okay.
Yeah. They're again. One is applying. Electrical engineers, generally speaking, are usually involved in power engineering, which is distributing light power around, and essentially electrical appliances, those sorts of things, as opposed to electronic engineers. Although today everything is getting so much electronics in it that they get mixed together as well. Like your washing machine, your stove now has a microprocessor in it, and so they're not even electrical anymore like they used to be. And automobiles have all kinds of computers in them now.
Now, how about this? You said there's also some industry-created engineering categories. Now, you touched on a few of these. Would you want to tell us a few others? It sounds like people have a choice to do quite a few things.
Quite a few, yes. Like for example, like you can get a certification usually in these areas like quality engineering, test engineer. I've never seen. I think there might be certificates in that. Then there are systems engineers, control systems engineers, and it goes on and on and on, depending upon the company. Companies invent titles in order to try to sort of characterize persons that are in their industry. So usually it comes out of industry and out of some specific new industry that evolves.
And then maybe a school has it as a minor or some sub.
You might take a minor in it, but sometimes it's really rare. I've never seen a school that taught, for example, test engineering as a minor. You just sort of pick it up as you go. It's something that needs to be done. It's part of quality engineering, and so you sort of get into engineering and then you move in that direction, and then maybe you might even go in the direction of design engineering, which is more where I am.
I just had a thought, a person that was studying engineering, if they did an internship in the sub area, they would have the discipline, and then some experience in whatever you said, test engineering or something like that.
Exactly.
Okay. Any other industry specific that you wanted to mention?
I've forgotten. There are so many. I remember when I looked them up, I could list four. Nuclear is one. And that's kind of like a subcategory of power engineering now, because most of the time it's for nuclear power plants.
And you mentioned structural engineering as part of civil engineering.
Yeah, that's the study of structures.
So why don't we talk a little bit about the overall education and training needed to be an engineer? And I know this varies, but to be certified and to be able to be believable, what somebody out there that's thinking of being an engineer, what's in store for them?
Almost always, without a doubt, they're going to have to get one of the major degrees, like mechanical engineering or electrical engineering. You can get them now. Computer science, since it's called an engineering discipline, now you can get degrees in computer science. Almost always, that's the route. Occasionally,
one of the basic, recognizable ones.
Yes.
Okay.
And I guess I lost track of what I was going to say, but the it all comes out.
No, the basic, whether or not they had to get certain degrees,
right,
and then maybe learn a subspecialty,
right,
but they have to get one of the basic six or whatever it is you said.
Right. Yes. Like a chemical engineer might go into semiconductor processing, or they might go into drugs, like you said, like you were mentioning earlier, or they might go into Monsanto, say, to help whatever chemicals Monsanto makes, etc. So. Anyway, that's but.
Okay. All right. Let's talk about the personality and skills needed to excel. I mean, what kind of characteristics? Oh, I did want to say one thing. I always felt bad for the engineers in school because they had to take, I was a math major as an undergraduate, math. They had to take the sciences, physics and chemistry, and engineering classes.
Right.
And the scientists, the physics majors didn't have to do that, and the math majors didn't have to do that.
But sometimes math majors do go into engineering, and also sometimes physicists go into engineers, make very good engineers. But that's because they narrowed down the physics is a broader discipline, and they just narrowed their discipline down. But you're right. You know, the usual thing that you hear is you should like math and science, right? In order to be an engineer, the hard skills, so to speak. And it turns out that because there's a lot to learn, most engineers end up focusing down in studying about things. So if you're saying what kind of characteristics a person has to like,
what kind of characteristics
things,
person
right? They need to like to take things apart or understand why things work, etc. If you don't have that sort of a personality that wants to do that, as opposed to being interested in people, which is one of the main complaints people have about engineers, is they tend not to be very soft and high in soft skills. But it turns out that if you are able to combine soft skills and the hard skills, you become much better technical manager, which is a very important skill. And of course, that's how you break away from the normal group of engineers who essentially stay working as just workers, essentially stay at the bottom rungs of the ladder. But a lot of people like that. I mean, they really enjoy being just doing pure engineering, just focusing on their specialty. But in the meantime, if a person doesn't like, you were mentioning characteristics, you have to like to focus. You're going to spend a lot of time in front of the computer, on the lab bench, or whatever. Lots of time focusing, and not too much time, roaming around talking to people or whatever. You're being paid to do a lot of focused work, and so you have to really like to be able to do that a lot.